whether the trained model is really doing great or not, right? So to understand that, we use the accuracy. And apart from this, we have something called precision and recall and FN score. And FN score is, arithmetic, the harmonic mean of the precision and recall. Yeah, so 1 second, I'm getting a call here. Sorry, today some releases are happening. Just give me a second, I'll be back. Hey guys, I'm back now. Sorry, I just took a minute to respond to them. Okay, I'm back now. Just give me a second. Yes. Look here. Yes, Deepa. Deepa's question is, what is precision, recall, and all? See, yesterday we discussed about confusion matrix. Okay, can someone tell me what is the formula for accuracy? How do you compute the accuracy? We discussed yesterday, right? How many of you noted down? Forget about recorded video. So tonight, we are uploading it. But you need to note it down with your pen and paper. Okay, take a pen and paper notebook and sit together. Yes, you are doing it already. I know that, Deepa. Okay, this is a common suggestion to everyone. Okay, so what is the formula for accuracy? Yes, you are correct. Shri, you are correct, and Deepa, you are correct. Okay, the accuracy, true positive plus true negative divided by all the values that are there in the confusion matrix, right? So first of all, what is a confusion matrix? Why do we need to use the confusion matrix? Type it in the chat window quickly. Yes, all of you are correct except one. So only one member did not respond. All of you responded correctly. Yes, confusion matrix, we use it to find out how well the model classifies the given instances, right? Yes, correct. You are correct. You are absolutely correct. Yes. So 1 second, let me just show you here. We can look here. This is the actual and this is the ones. Okay, this is zeros and ones. And in this case, the churners, right? The zero is non-churners. So out of the total number of records, 1 second, let me just go up here. Yeah, the 1,603 customers are non-churners, which means they are still with us. They did not leave us. Out of 1,063, 1,027 customers, my model correctly predicted as, non-churners, but wrongly predicted that, they are, churners, right? 11. And here actual ones predicted zeros. Look here, instead of giving it here, the predicted zeros, predicted ones. The model predicted 11 customers as churners. Actually, they are non-churners. That's why I told you my model wrongly classified 11 customers as the churners. Actually, they are not churners. Whereas here, the 155 customers, my model predicted non-churners. Okay, actually they are churners, but my model wrongly predicted they are non-churners. So predicted ones. So actual ones. This is correctly predicted, right? So predicted and actual, both of them are same. Actual and predicted are same. The actual and predicted supposed to be same. But here, there are cases, even like I said, like human, the machine learning models also not, correctly predicting it. Okay. There could be some kind of, misclassifications can happen. With the help of confusion matrix, as rightly pointed out by Deepa, we can find out how many number of records or observations were correctly classified, how many of them were wrongly classified. We can find out. So with for the accuracy measure, this is the basis. Which one? The confusion matrix. True positive plus true negative divided by all the values. All the values. Okay. Okay. Next one is the precision and recall. As you asked this one, right? Model evaluation. Yes, precision and recall. So we can use the precision and we can get the precision recall FN score using the classification report. So there is something called classification report method that is available as part of this package. You need to import this. You need to pass the actual and the predicted labels, actual labels and predicted labels for your test data set. Okay. And with that, when you pass this one, the classification report, this method prints something like this. There's some precision, recall, FN score support. There's zeros and ones, accuracy, macro, average, weighted average, everything is there. Fine. So here, if you see here, the precision is 0.30, recall is 0.4. But what is my, the accuracy? Accuracy tells 0.87, which is closer to 1. That doesn't mean, right, the accuracy is really great still, but when you look at the precision and recall, you can see the precision is 0.30 and recall is 0.4 only for 1. What is 1? 1 is churner. What is the objective of this exercise? What is the objective of training this machine learning model? All of you type it in the chat window. What is the goal of training this machine learning model? The logistic regression in this case study. Yes, 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 yes. 4 of you correctly answered. Okay. So here, the objective of this one is, as you all mentioned correctly, we wanted to predict the one, right? We want to predict the one. Which customers are more likely to leave our business? Okay. So, but here, accuracy is misleading us. It tells us it's somewhat closer to 1, whereas when you look at the precision and recall, it is not, absolutely good. So, what exactly precision and recall? That is what the next question. Okay. 1 second. So, precision, right? When the false positive cost is high, then you need to use the metric called precision. Instead of using the accuracy metrics to decide whether my model is doing good or not, right? If the false positive cost is high, then you need to look at the precision, the values that are there in your precision. So what do you mean by false positive? Like I have shown you here. Look here. And here, which one is false positive? So predicted ones and actual ones. Okay, this is a true positive. This is this is a true positive. And this is a true positive, this is a true negative, right? Negative and 0 means they are non-churners, okay? But here, the 11, right? 11 is predicted ones. Okay, wrongly, it predicted it is positive. Positive means they are churners, but actually they are not churners. 11 customers, my model predicted them as a churner. It is a falsely, it assigned the classification as positive. Falsely assigned the 11 customers as positive. Falsely assigned positive to the 11 customers. We can see that way also. So again, it depends on your requirement. For example, if the customer says, or if your business suffers because of the false positive cost is high, then this one you need to reduce it like anything. Okay, that is what the objective. See, you can train the model, everything is plain vanilla. Even a 12th standard CBSE guy can train everything, right? Even a 10th standard CBSE guy can do everything. Nowadays, even 10th standard, 8th standard CBSE syllabus itself, artificial intelligence is there, right? So what is our role as a data scientist? Everything is plain vanilla, everything is available. In this case, my model wrongly predicted 11% are positive, which means they are churners. Actually, this is actual, okay? They are not churners. Our objective is we want to reduce it. So in this case, it is okay. 11 is negligible. 11 customers, my model wrongly predicts churners, but you are going to oddly contact, 11 more customers. That's all. If the value is too high, you are mistakenly calling many customers to check, hey, don't leave me my business. Why are you not purchasing? Why are you not reading, right? So it's waste unnecessarily. It's something like, the person is healthy, actually 0, which means, they are not cancerous person. But, my model wrongly predicted they are cancerous. Even if my model wrongly assign in that kind of situation scenario, it is very, very expensive, right? The cost is high. Positive cost is very high here in this case. Hence, try to make it 0. But that is not in our hand. We need to do some gimmick here, right? We need to do the feature selection, and we need to find out which features are significant, which features are not significant. And you need to do some kind of hyperparameter tuning, everything. And somehow you need to reduce it, okay? And then the next one is the false positive. This is what is precision. So you need to look at the precision. If your business is going to suffer, if this cost is very high. For example, in the case of banking, you wanted to predict which all transactions are fraudulent transactions. Even though a lot of securities are there in the case of banking system, still there could be chances of having some kind of hacking, right? Fraudulent activities. So in that kind of situation, if the model predicts the non-fraudulent transactions as fraudulent transaction, it is not going to impact you. Actually, you are suspecting, hey, 11 transactions were fraudulent transactions. But when you start, take a look at the data, everything, finally you can, no, it is not a fraudulent thing. It is okay. Even if the model misclassifies it as a fraudulent transaction, actually there is no fraudulent transaction happened. You did not lose any money. What about here? False negative. My model falsely assigned 155 transaction as negative. Actually, it is a fraudulent transaction. 155 transactions were fraudulent. Even one fraudulent transaction happened, banks cannot afford, isn't it? Yes, Deepa, you're correct. I'll tell you that one. Deepa and Sri, wait. So even one transaction, let's say that one transaction itself, they made 10 crores worth of transaction, right? It is going to be gone. Even if one transaction they made with a huge amount of money, your business is in trouble, right? So here 155 is there. In that kind of scenario, it is not acceptable. That is what recall. If the false negative cost is very high, if the high cost associated with false negative, then you need to look at the precision. So, and if you look at this one here, recall, and recall shows here precision. Okay, I was wondering, no, not this one. We will look at this report, yeah. And if you look at here, you can see the precision is just 0.30 only. Okay, the recall is 0.04 only. Let's put this scenario here, banking transaction, right? So actually fraudulent 155 transactions were fraudulent transaction, by model wrongly assigned, it is non-fraudulent. That means my model is not doing good job. You need to look at the recall in that kind of situation. Literally don't go by your precision, sorry, the accuracy. Okay, so in the same bank example, if my precision is not that high, not that high, that is fine. But this one's supposed to be very high, the recall. Okay, so even the case of churn model, what happened here? Even the case of churn model, my model, wrongly classified 155 emails as non-spam. Actually, it is spam email. Even in the case of Sam's spam scenario also, this is not affordable, right? That is the reason why when you see here, the recall in this case, the recall, it shows, that means my model is not doing good job. It is not correctly classifying the spam as spam. It wrongly classified the spam as non-spam. Even in the case of banking, it will have a serious impact. Okay, what can I do? What should I do? Why am I getting like this? So for that, when you look here, if you move up and see here, and how many number of customers are churners, how many number of customers are non-churners, right? When you see this one, you can see here, 1 second. Yeah, you can see that 237. If you divide the true number of churners by non-churners, 14%. Okay, if it is 5 to 8%, right? Ideally, the non-churners and churners related records are somewhat close by. Let's say 60% of my data set, 60% of my records in my data set are non-churners, 40% are churners. Then it is a balanced data. But here only few customers are churners, majority of them are non-churners. So in that case, if you go by accuracy, it will bias towards more number of records that are, in this case, that are non-churners. And then your accuracy will show high. Okay. So hence, the other way of doing is, we need to do feature selection, everything. And apart from this, you need to handle this, you need to handle this unbalanced data set, imbalanced data set. Okay, imbalanced data set. So because the ratio should be somewhat closer, the number of churners and number of non-churners somewhat closer, right? If it is the number of records are not somewhat closer, then also it will be biased towards the negative values. Okay, in this case, the negative values are more. Negative values means zeros. Okay, remember this. Got it? Okay. So now we discussed about when to use precision, when to use recall. I'll just write the formula here again. Remember this, in the interview they'll ask you everything. Guys, interview is pretty tough. Don't think, simply I walk into office, they will give you salary every month 1 lakh. No. If you are a capable person, they're ready to give, even for 2 years and 1.5 years, right? They give close to 80,000 now. True positive plus, you need to remember everything. Everything should be in fingertip. Okay, true positive. Precision is nothing but true positive divided by total predicted positive. Total predicted positive. That is what your precision is all about. So here I just write it in a matrix. So let's say now we have the actual and you have the predicted here. Okay, I will write it little. Okay, your actual is negative and it is positive. Here it is negative and positive. Okay, Let's know this is what you were predicted. This is true negative. This is false positive and true positive, and here false negative. This is your actual, this is what you predicted. Okay, and here this is negative positive. So actually it is negative, which means they are non-churners. My model also correctly classified them as a non-churners, right? We can say negative also, okay? See, don't say I get confused. Customers will use different terms, okay? Here, negative means 0, positive means 1. Either 0 or 1 will be there, negative, positive. The interview don't tell Americans, hey, you know, can you ask the questions in a way how I can understand? No, you should be in a position to, you should be very dynamic. You should be in a position to understand, even if they ask questions in n number of ways, you should be able to correlate and analyze, and you need to give the correct answer to them. Negative and positive, which is negative 0 and mean 0 means non-churners, okay? Here also 0, 1. So my model predicted, this is predicted, true negative. Okay, let's 50 customers. Let's that way, okay? And or let's sorry, in our case, so approximately 1067 customers. My model correctly predicted negative, which means they are non-churners, right? And positive is here actually they are churners, but my model wrongly predicted as non-churners. False positive, right? This is your false negative. And when it comes to precision, you need to look at this quadrant, false positive and true positive. And if you relate this one with this equation, so true positive divided by, you need to add these two values. Okay. So what does it tells actually? If you look at this plain English language in the denominator, true predicted positive. See, this is predicted, right? So this is predicted positive. This quadrant tells positive, but here it is false positive, true positive. Actually, the this one supposed to be, this one supposed to come here, right? This one supposed to come here. Out of this total predicted positive, so these are positive, right? It's a true positive, false positive. End of the day is positive. Out of the total predicted positive, how many of them are actually true positive? If you simply substitute here, for example, predicted positive is 11 and total positive is churners, right? Churners, let's 8 or let's 22. Okay, so true positive is 22 and plus 11, how much? 33. 22 divided by 33. Or let's say, let's use some even numbers so that let's you have something like 4 and true positive is let's 2, right? Yeah, true positive is 2. The numerator, the denominator, let's if you add all this means 6. 2 divided by 6, which means 1 by 3. 1 by 3, right? 1 by 3 is how much? 0.3, right? 0.3. Yes, 0.33. Your precision is 0.33. Okay, your precision is given this scenario. Okay, I just gave you some sample data here. 2, 4 and 2 here. Okay, so that our calculation will be simple, 0.33. For example, your true positive is, let's 10. So in the numerator, 10 will come and your false positive will, sorry, here you have 14, right? 10 divided by 14. So how much you will get? So 1, right? So higher the values in the denominator, obviously your accuracy will go down, right? For example, your true positive is, let's 100. 100 divided by 104 will come, right? So here, listen, you have just 2 only. So, and 102, 100 divided by 102. What will happen? Your denominator value get reduced, right? how much you will get. So here also you get this one only, right? Yeah. So ideally the precision should be more, which means the false positive rate should be less. It should be very, very less. You need to that is what your objective now. So that is what the goal. They will set you, your manager, American, they will tell you, hey, you need to reduce the false positive value, man. Why it shows 140? For example, if you have 140, 100 is there, 240, right? 240. So your accuracy will fall down like hell. Okay. So they will raise a big concern and they will ask you to reduce the false positive. No matter what you do, you have to reduce the false positive. That's when you need to check whether the given data is balanced data set or imbalanced data set. In case of imbalanced data set, you need to use some technique, okay, to make it balanced, and then only you need to retrain the model. So there is separate topic for handling the imbalanced data set. Okay, that we will discuss it later. Okay, so what is precision? This is the formula for the precision. True positive, total predicted positive. Next one is recall. So when will you use the metric recall precision? When the false positive cost is high. When the false positive cost is high, then you need to look at the precision, not the accuracy. Even though the accuracy shows more, don't worry about that. Okay, it is maybe sometimes it may mislead you. As I told yesterday with example, right? Yes, you're not supposed to use the accuracy in all the time. There are scenarios, accuracy is completely meaningless. And depends on your situation. You need to decide what kind of metrics you need to look at it. Can I use precision or can I use recall? When can I use recall? Can someone tell me now? Yes, Deepa, you are correct. Good that you people are writing it down. But. So then you don't have to watch my video, right? If you can watch my video only for review sake. So Anwar, you are correct, and Sri, you are correct. Deepa, you are Swarna, you are not correct. Okay. Recall. I asked about recall. Yeah. Recall, I'm yet to write it, the formula. But what is the idea of the recall? That is what I asked. When will you use recall? Guys, joining the call and supervise me whether I'm taking the training or not helpful. You need to note it down, only then this one will be helpful. Okay. So good that out of 5, 3 people answered correctly, and Swarna misunderstood. Okay. I'm not asking you to write the formula, Swarna. Why don't you write when can we use recall? That is what I told you a while back. When can you use recall? Yes, you are absolutely correct. When the false negative cost, see, false positive, false negative, right? When the false negative cost is high, then you need to use recall. Yes, you are correct. Good that even though you all working, still false negative cost is high. In that kind of situation, you need to use it. So in that kind of situation, tell me the confusion matrix. Which quadrant needs to be taken into account. Here, in the case of recall, the formula is true positive divided by true positive plus false negative, because recall is meant for false negative, right? And here, same as precision, the numerator true positive, the denominator total actual positive. Total actual, sorry, this is positive, okay? This is total predicted positive. This is the total actual positive. So I'll give you a simple analogy. Let's say you have predicted how many number of votes can be secured by the ruling party. That is what you predicted. Right? Out of the total predicted positive, for example, you predicted the ruling party will get, let's simple example, okay, 100. This is the predicted positive, which means 100 seats, 100 votes, they may get it. Ruling party. This is what you predicted. This is the total predicted value by your model. Out of which, how many of them are actually, positive, right? After election, let's they are getting only 50%, 50 votes. This is you predicted, but the reality is only 50. Only 50 people, casted their vote. So here, what will happen? 1/2 is 50%. Your prediction is just 50% only, right? This is the predict in the denominator. What you predicted, but whereas in the case of recall, what is the actual positive? Okay, so just because you predicted 100, that doesn't mean, right? So yeah, so that doesn't mean, okay. So let's take this example: true positive, right? And divided by true positive plus false negative, right? That is, yeah, true false negative. That is nothing but your total actual positive. You predicted 100, but actually how many of them are 100? Actually how many, right? See, actually 150, let's assume that 150 were positive. There is a 150, you can get, this specific party, they can get 150 votes. Or, or let's say 150 votes. But your model predicted only 100 of them are positive. Out of these 100, how many of them are, how many votes they got it in reality? Only 50. Okay, so that means 50 votes, your model was not at all predicted as positive at all, right? So whereas if you look at this example, instead of 100, forget about your model predicted positive 100. What is the actual positive? 150. 150 votes were actually casted by the people, and the true positive, out of the actual positive, how many of them are actually positive, predicted by positive in your model? Let's say even if you say 50, right? So 1/3, 0.3. That means, it is not good, right? So both you understood, right? What is the difference between these two, precision and recall? In the case of precision, both the cases, the numerator is true positive, the denominator is true positive plus false positive, which means the predicted positive, right? This is wrongly predicted as positive, but tell me wrongly predicted positive and then truly predicted positive, and you need to add all the things. That is the predicted positive. But in the case of recall, you need to add false negative plus true positive here. Okay, and total actual positive. Okay, see, for example, you have something like, different types of fishes in a pond. Pond na theriyala kulam, small river, or something. And then you have something called negative, different types of fishes. For example, these are all Vajram fishes. These are all some other type of fishes. Okay, and listen, you are casting a net. Something like you are making a prediction. In your net, out of this 6 plus, and how many are there? 3, 5 negatives. Right here in உங்க வலையில வந்து எத்தனை விழுந்திருக்குன்னா plus. ஓகே, நெகட்டிவ் பார்த்தீங்கன்னா வந்து அவுட் ஆஃப் 5ல வந்து 1, 2, இந்த 2 கேட்டகரி மீன்ல, ஸோ பிளஸ்ல வந்து எத்தனை இருக்கு? 7 விதமான மீன். 7 மீன்ல பிளஸ் மீன்ல 5 மீன் தான் உங்க இதுல பிடிச்சிருக்கு. அப்படின்னா மை மாடல் ப்ரிடிக்டட் ஒன்லி 5 out of 7, and right, that is what the true out of the predicted positive, how many of them were actually positive? The predicted positive பண்ண இதுலயே வந்து நீங்க மீன் பிடிச்சிருக்கிறீங்க. ஃபார் எக்ஸாம்பிள் இதுல வந்து இதுல வந்து எதன இருக்கு இதுல ப்ரிடிக்டட் வந்து இது வந்து ப்ரிடிக்டட். பட் இதுல உங்க மாடல் வந்து எவ்வளவு கரெக்டா ப்ரிடிக்ட் பண்ணிருக்கு. நீங்க என்ன பண்ணிருக்குன்னா, யூ ஜஸ்ட் இதுல வந்து என்ன நினைக்கிறீங்கன்னா, இதுல வந்து சரி மைனஸ் போட்டுக்கலாம். 3 பிளஸ் 2 மைனஸ் இருக்கு. பட் டோட்டல் ப்ரிடிக்டட் பார்த்தீங்கன்னா 5. இந்த 5ல எத்தனை வந்து பிளஸ்? யூ வாண்ட் டு ஃபைண்ட் அவுட் ஹவ் மெனி ஆஃப் தெம் வேர் கரெக்ட்லி ப்ரிடிக்டட் ஆஸ் பாசிட்டிவ். வலைய போடுறதுன்னா நோக்கம்னா, நீங்க வலைய புடிச்சுட்டு என்ன பண்றீங்கன்னா, வலையில மீன் விழுந்துருச்சு எடுக்குறீங்க. எடுத்துட்டு என்ன சொல்றீங்கன்னா, "ஏய் 5 பாசிட்டிவ் மீன் வந்திருக்குன்னு" சொல்றீங்க. 5 மீன் புடிச்சுட்டேன். ஆனா, அது ஓப்பன் பண்ணி பார்க்கும்போது தான் தெரியுது, அந்த 5ல வந்து 3 தான் வந்து பாசிட்டிவ், மீதி 2மே வந்து நெகட்டிவா இருக்கு. ஸோ, டோட்டலா எத்தன மீன் இருக்கு? நீங்க பிரெடிக்ட் பண்ணது 5 இங்க, இந்த டினாமினேட்டர்ல. ஸோ, ஆக்சுவலி இந்த 5ல எத்தன வந்து பாசிட்டிவ்? ஒன்லி 3 தான் பாசிட்டிவா இருக்கு. இந்த கேட்டகரி தான் இருக்கு. Okay, this is a simple example for you to understand. And this one, total actual positive. இதுல என்ன சொல்றேன்னா, நீ எத்தனை புடிச்சிருக்க, நீ வந்து 5 புடிச்சிருக்க. 5 முக்கியம் இல்லப்பா. மொத்தமா எத்தனை வந்து பாசிட்டிவ் இருக்கு, அத சொல்லு. ஸோ எத்தனை மீன் இருக்கு அதுல மொத்தமா அந்த குளத்துல? இங்க எவ்வளவு இருக்குன்னா 3, 4, 5, 6, 7. 7 ஃபிஷஸ் ஆர் தேர். டோட்டல் ஆக்சுவல் பாசிட்டிவ் வந்து 7 இருக்கு. இந்த 7ல நீ எத்தனை புடிச்சிருக்க? 2 தான் புடிச்சிருக்க. 2 அவுட் ஆஃப் 7. சரி 3 தான் இல்லையா? 3 அவுட் ஆஃப் 7. அவுட் ஆஃப் தி டோட்டல் ஆக்சுவல் இந்த மொத்த குளத்துல இருக்கிறதுல வந்து உன் மாடல் வந்து எத்தனை வந்து கரெக்ட்டா வந்து பிளஸ்ஸ புடிச்சிருக்கு? 3 தான் புடிச்சிருக்கு. 7க்கு 3 தான் புடிச்சிருக்கு. அதுதான் ரீகால். புரிஞ்சுதா? சாரி தீபா, ஐ அம் டாக்கிங் இன் தமிழ். See the point what I am trying to say is out of the 4 7 plus type of fish is a total actual positive type of fishes. Out of the in the denominator 7. Out of the total 7, how much your model, let's say your model or your when you in your net, if you had captured 7 out of 7, then your recall is really great. You are an expert in fishing. You want to capture only plus 7 out of 7. That is what your recall. Okay, in this case, okay. But because the denominator out of the total number of plus fishes available, how many of them you caught? Whereas in the case of precision, out of the caught fishes, 5 fishes you caught, that is what the predicted one, total predicted one. In that, how many of them are actually positive? 3 out of 5. You got it? That is what this one tells. Question, what kind of scenario? In the interview, they'll ask you what kind of scenario. See, now, I'm going to set up a call with a startup company in Chennai. They told very clearly, we don't care about the education. End of the day, how smart are the people are. Okay. Maybe 1 second. See, maximum, the maximum, if you remember, 6 to 7 metrics, that is more than sufficient. It might appear as the fancy words like precision, recall, accuracy, and AAC, BIC, plus AUC, area under the curve, right? So in addition to all the things, you need to use something called area under the curve. If the area under the curve is closer to 1, if the AUC value also, area under the curve, in the interview they'll ask you, can you tell me the metrics that you have used to evaluate your classification model? Tell all the things. AUC is somewhat should be closer to 1. You will not get closer to 1 in the ideal world. Maybe you will get somewhat 0.7 or 5, 0.75. That means it is good. And again, you need to make sure that your model is generalizing well. What do you mean by generalizing well? I told you 10-fold cross validation, right? You can use that technique and see you don't have too much of variation. And the error is also not much. And if the variation is not much, then you are lucky. Okay. Let's say now with that you are getting 0.75. Though 0.7 is not very close to 1, it is okay. At least your model is generalizing well. But still, the customer will come and sit on top of your head, and then they will say the false negative cost is very high. You need to reduce it. We cannot afford this one. In that matrix, the false negative cell should show 0. That is what they will ask you. That is where the feature selection technique, everything used, hyperparameter and everything, you need to use it with that video. So now I just go back to my this one. And here we have another matrix called log loss. Log loss also I'll discuss it later. Okay. And if you look at this one, guys, this is very simple. See, except see all the lines up to confusion matrix, it is very common to all the other sorry, up to you know except this one. Okay, fitting the logistic except this one. So only thing what you need to do, instead of logistic array, you need to use random forest. All the algorithm, you know, you need to copy paste this. Here simply all the steps are same. You just scroll down here. Look here. Here what did I do? Look here, random forest classifier. So you know, I initialize the random forest classifier. So now I'm going to fit the method, the input features, output features of your training data set. That's all. Your random forest model is ready. Similarly, you put light GBM, light gradient boosted machine, and gradient boosted machine. Gradient boosting, look here, gradient boosting classifier. That's all, guys. This is what machine learning is all about. And for check for each and every type of algorithm, what is the accuracy and what is the precision and recall. And whichever algorithm gives, you know, higher precision and recall, that means good. Okay, and that means good. But again, you need to test it with training and test data set. But here, what you see is the training data set. Okay, for test data set, what is the precision recall? You need to check it out. Okay. Yeah. So how do we increase the sensitivity? For example, they are very stringent. Okay. If the probability of churn is 0.9 and above, then that means you are increasing the sensitivity. So they use the term called cutoff. In the case of logistic regression or other classification model, they use a term called cutoff. By adjusting the cutoff values, what is the you know accuracy that you are going to usually they say, you know, 0.8 probability. That means the customers are anytime they are going to leave. They are really potential customers. You are going to lose the customers, right? Point and above. There are some business movement. Again, depends on your affordability. Let's say if your customer with 25 million records, out of which, let's 25 million out of which 1 million records, 1 million customers you expect as per your model, they are going to leave your business. Do you think you can call each and every customer? 1 million customer you can call. Even 1 million is too high. You need to hire so many staffs. Right? So in that case, they increase the sensitivity. So if the predicted probability for churning is more than 9.5, that means it will reduce. So let's let's take a simple example. Let's say you have 1,000 customers. Out of 1,000 customers, so we could see that 50 customers are more likely to leave. The risk is 0.9. There is a 0.9 probability out of 100 customers or 1,000 customers. We expect 50 customers are going to leave anytime. We can call 50%, right? Even 50 is too high, but still, in a week time, your staffs can, even with 1 or 2 staffs, they can finish up calling the those risky customers, which means those customers are about to leave your business. Call them and find out them, address their issues, and make sure that you are relating the customers by giving some offers or something like that, so that So in that kind of situation, if your total customer base is not so high, and your probability, right, 0.9 and above, you can decide. So why 0.9 and above? That is what the question from Deepa now. See, it is up to you. Let's say you know the business, you got assigned to the project, and you know the sensitivity, you are into telecom domain, and you know the sensitivity, right? How sensitive the customers or your business is. If your telecom customer base is, let's 1 million customer, out of 1 million customers, you can expect 1,000 customers may leave with 0.9 probability, and if you can afford to contact those 1,000 customers, then go ahead. Or you can increase the sensitivity 0.95. எவன் ரொம்ப டேஞ்சரா இருக்கணும் அவனை மட்டும் கால் பண்ணா போதும். அப்போ என்ன ஆகும், நம்பர் ஆஃப் churners will get reduced. இப்போ எனக்கு 1 million வந்து பார்த்தீங்கன்னா இப்போ வந்து instead of 1,000, let's we could see that only 250 customers are more likely to, they are in the danger zone. So they are standing very close to the fence. எந்த சமயம் வேணாலும் அந்த பக்கம் இருக்கிற வேலையை தாண்டி போயிடுவானுங்க, அப்படின்னா காம்படிட்டர் போயிடுவாங்க. So in that kind of situation, you need to increase the probability and cut off, right? You need to, that is what the sensitivity tells you. This one I explained you in my yesterday's video. Anyhow, tonight, right, we are going to upload all the videos. Next one is k-fold cross validation. Like I explained you in linear regression, even for the logistic regression, all the other types of model, it is always good. You can use k-fold cross validation, and you know the logic, right? And cross val score. Look here, instead of giving the R squared value here on like linear regression model, in the case of classification, it gives you the accuracy value. But if you see, almost all the values are same, right? All the 5 folds, 6.657, we don't see too much of variation. If you see something like 0.50 and rest of them are like this, then there is a variation. But it is somewhat closer. That means we can roughly conclude that my model is generalized well, but the accuracy is not so impressive, right? So ideally, if it is closer to 1, that means it is good. But still, my model generalized well. It did not memorize. So next step is to even try to improve this one, right? Accuracy. See, the variation should not be more, and your accuracy should also be more. Right, it's that is what the challenge, real challenge. And A is area under the curve. If you see the area under the curve, 0.5 and 0.51, it is somewhat closer. Okay, next one is the feature selection. Feature selection will be discussed on recursive feature elimination. What it does is it includes all the features in your model, and out of the all the features, what we want this model RFE is to do the out of the give me the top 8 features that are helpful in terms of predicting my target outcome variable. Okay, so here it gives you false or true. Whatever the columns or the features that got marked as flagged as true, you can include those, only those features, input features. Rest of them you can knock it down and again retrain your model and do the same step again. Okay, and you check the accuracy, check the area under the curve, and check the precision and recall. If it is really good, then your job is over. Okay, then your job is over. Next step is the implementation. Okay, what is that, Deepa? And she says, can you end the session? We want to review it. Can we have one more session during the weekdays? Because we have so many things to cover. Yes, Shri and Deepa, it's a valid point. I'll just check and let you know. But this week also I'm busy. Saturday, Sunday we'll spend more time. In the meanwhile, you can watch my video. Since you all asked about you need some breathing time, understood, you need time to practice everything. Guys, don't ever say I don't have time. Everybody, every day people are working. Even in our office, 35-year-old young guy, is taking tablets and he's working day and night. Okay, that's all. End of the day, yes, if you wanted to retire at the age